So generally speaking, transformer looks something like this. Okay. So what we do is we wind some coil on this side and then we wind some coil on this side. So the voltage across this we call it as primary voltage and this one we call it as secondary voltage. The number of turns here it's called NP. Number of turns on this side is called NS. Okay. So the EMF which is given on this side is minus N d phi by dt, change in magnetic flux. So I think the other day I showed you, I can show it one more time here. So I showed you this is a working transformer, right? So on one side I can connect this to the power outlet which is 220 volts. On the other side I will be getting a 9 volt. You folks remember I showed you, blowing this bulb, right? So if you directly connect 220 volts for this bulb, I am sure it will be blown up very quickly, right? So within a few seconds it will be gone. Whereas this one, since it is 9 volt, actually this bulb can take only up to 6 volt, but just for trial I just gave 9 volt, but still it was okay, it was working. So this is what a transformer looks like. So this side is called the primary coil and this side it's called the secondary coil, and in between you have some solid core, iron core. So I can show you something here, let's see. So you can see the wire here, coils here. So just for diagram we are showing it like this, but in reality you will be having like thousands of coil, right? Thousands of turns. Okay. So yeah. Transformer is used in colony. Yeah, everywhere in the streets you will see transformer. Why? Why do you have a transformer in the streets? So the voltage which is coming from the power plant, right? So it will be at very high voltage. Okay. So you want to reduce it before entering into your home or office. Okay. So only 220 volt is what your home can take. Okay. But there are some industries where they need 440 volts, right? So there the transformer will be different. But most of the transformers which you are seeing in the street will be 220 volts. So it will be reducing it from a very high voltage to it will be low voltage 220. So it's called step down transformer. So it's something like from the power plant in the highways you see those big towers, right? So in there I think it's something like 132 kilovolts. So 132,000 volts, right? So it's a huge voltage. So what they do is they increase the voltage from the power plant. So I think they will be producing around 20 kilovolt or something, but in spite of that they will increase the voltage and then it will be coming in the lines. And then when it comes to a street, right, of course there is something called a city substation or something, this power house and all these things, right? So they reduce the voltage a little bit there, and then when it comes to a street, right, it will be reduced further. So from your street, when it gets into your home, it will be around 220. Okay. Yeah, good question. So when voltage is reduced, what happens to something else? How come we say? Yeah, so there is a concept, we have to study the concept of transformers. So what is the most important law in physics? Conservation of energy. So the energy which you give on one side is same on the other side, assuming there is no losses, right? If I lost some 10 percentage, then I will be getting only 90%. But it's never going to be, if I give 100, I am not going to get 110. It's never going to happen, right? So the losses will be like say 10% or 20%, something like that, which means I will be getting only 80%. So coming back to your question, when we say voltage is increased, the current will be reduced. Okay. Because again, we need to study the alternating current, right? Why we use this kind of system. Only then it will make sense. So why can't we use direct current in our homes? It's too much. 220 volts is not too much. Same 220 volts, why can't we use? Lot of heat. Okay, so alternating current is cool then. I can go and touch it. Less dangerous? No. So the answer lies in transportation. Okay. So when the energy is produced, right, you can produce it as alternating current or direct current. You can produce either way. But then when you transfer it from the power plant to home, right, let's say it's like 100 kilometers away, right. So let's say the power plant is somewhere 100 kilometers away from the city. By the time the current is coming here, already there will be some heat losses. You study this Joule's law of heating. So whenever there is some current flowing in the conductor, there is some heat loss, which means by the time it comes through 100 kilometers, right, it has already dissipated a lot of heat. So if you send 100 units, by the time it comes to your home, probably it will be 1 unit or 2 units, right? So which means you will be losing a lot of heat. So to overcome this, using the alternating current, right, they came up with the idea where when you use transformers and increase the voltage, the current will decrease. So when the voltage goes up, current will come down, which means power is equal to I squared R. Have you studied that somewhere? Power is equal to I squared R. Power is V into I. So in place of V, I can put IR. So it becomes I squared R. So that means if the I is big value, right, the power loss will also be higher. If the I is smaller, the I squared R losses will be smaller. So that's why we are using alternating current. Okay, so we'll be studying this in the next chapter, which is AC current. For now, I want you to go through this, take a look at this. So the important thing I want you to observe is, it's not a single piece. Can you see this? There are a lot of small plates. So this is one plate, like that you have a lot of plates. Okay. So the transformer is not made of one single solid piece. Instead, it is made of some laminated sheets. It's called laminated sheets, small sheets. Okay. So all these sheets are put together, and in between you have some kind of a insulation material. It's called lacquer. LACQUER. Okay, lacquer material. So that's what we are going to talk about. This is one situation where eddy currents are undesirable. So they may ask you a question, where eddy currents are undesirable. So transformer is one place where eddy currents are undesirable, and how to reduce that? That is the answer. So I told you it's not one single solid piece. Instead you have laminated sheets, okay, with some insulation material in between. So look at this. So instead of showing it as a solid piece, you have to show it like a laminated sheets like this. So a lot of small pieces. So let me give you some details here. Transformer. So please listen here. Is this coil and this coil, are they physically connected? No. This is wound here and this is wound here. So whatever magnetic flux change here will be conveyed over here. So as the current here changes, right, there will be some magnetic flux changing in this solid core, right. So as the magnetic flux is changing here, what will happen? The magnetic flux around this coil will also change, which means it will be inducing some current. Are you following what I am saying? So that's the principle of transformer. So transformer is nothing but what I showed you earlier. So on one side you have one set of coil, on the other side you have another set of coil. When the current is changing on one coil, it will be inducing some other induced EMF on the other coil. Okay, are you following what I am saying? So that's the principle of transformer. Only thing, the construction is different. So take it down. Changing magnetic flux causes eddy currents which dissipates as heat, which is undesirable. Changing magnetic flux causes eddy currents which dissipates as heat. Which is undesirable. Okay, so they may ask you, give an example where eddy currents are undesirable. So are you folks able to see that laminated sheets? So instead of one single solid core, it is laminated sheets. What do you mean by lamina? I'm sure very often. Thin surface, right? So lamina refers to thin sheets where the height can be ignored, which means you don't have the third dimension, it's only the two dimension, right? So it's like a lamina means 2D. So laminated sheets means it's almost very thin. That's the meaning actually. Those sheets, can you see that separate sheets? Can you see this separate sheets there? That is what is called laminated sheets. That is what is called laminated sheets. Instead of being a single core, right? So try to understand this. You're following this. So I can have a transformer like this. So I can have it as a single piece. But then if I have it as a single piece, right? So Ajay and Amrit, why every day you are coming so late? Okay, then you will be missing all these things. How are you going to catch up? I don't know. Every day you keep telling the same excuse. What about you, Amrit? So please listen here. So instead of having a core like this, so this is like a solid core. This is like a laminated sheets, not solid. Okay. So if I had it like this, what they are saying is, the concept here is, you will be producing a lot of eddy currents here. So the eddy currents will be produced here. Okay. So to reduce this eddy currents, right? So what the technique is, we have to use it as laminated sheets. And then in between the sheets, right? So this can be shown as something like this. So I can say these are all the laminated sheets. And this is your insulating materials. So take down this properly. So this is your laminated sheets. This is your insulating material. And the material here which is used here or which is given in your book is lacquer. Lacquer. So what is the difference between the solid core and this one? Don't you think here also there will be some eddy currents produced? Here also we can produce eddy currents, right? But then this is a solid core, which means it's going to be like a huge area here. Whereas here, so in this one, the theory says that you will be producing eddy currents, but it will be very small. So something like this. So you have to take down this and this next to each other. Okay, so this is for solid core and I am showing the side view. So this is again the side view. Have you studied MIA? M is equal to IA. So that means M is equal to IA, right? Small I, capital I. So if the area is bigger, right, magnetic moment will also be bigger. Whereas here if the area is smaller, M is equal to IA. So if the area is smaller, this will be smaller. So I can say this is high, this is low. Okay. So I think this is one thing which I didn't cover earlier when I did the eddy currents block, because I thought I have to give you some understanding about transformer. In transformers, eddy currents are not desirable, or not. Why? How to overcome the problem? So this is the answer you should write. So you should say that in transformer, eddy currents are not desirable because as it produces eddy currents, the energy will be lost in the form of heat, okay, which dissipates as heat. Okay. How to overcome the problem? So this is the answer. So you should say that instead of one solid core, they have laminated sheets, and even between the laminated sheets there will be some insulating material. So because of this insulating material, the current cannot be produced continuously like this, right? So it will be producing only in a small region. So because of that, they have found that it is low eddy currents and it will reduce your eddy current losses. Okay, so you have to explain that because of this, the eddy current losses will be lower. Is this clear? So transformer based eddy current thing, this is what they will ask you.